In this video, I'm going to go through vector projections. So let's say I have the vector A and B, and the angle between them is theta. So the projection of A onto the direction of B will be this line right here. And then the projection of A onto the perpendicular of B will be this line. So I'm going to label these two lines. The red will be C, and the green will be D. So do note that C and D, they are both distances, and they're not vectors. So now we can write our trig ratios. So we're going to get cosine theta equals to adjacent over hypotenuse, which would be C over the magnitude of A. And do note that I'm using magnitude because when we're using trig ratios, we're talking about distances and not vectors. So we can rewrite this. C is going to be equals to the magnitude of A cosine theta. And if you remember our formula, cosine theta equals to A dot B over the magnitude of A times the magnitude of B. If we multiply both sides by the magnitude of A, we're going to see that our A's cancel on this side. So we're going to get magnitude of A times cosine theta equals to A dot B over the magnitude of B. So now we can rewrite C as A dot B over the magnitude of B. And because C is a distance, we're going to put a modulus over A dot B, just so that we don't get a negative distance. So D is going to be the magnitude of A sine theta. So again, if we use our formula, if we multiply both sides by the magnitude of A, the magnitude of A's are going to cancel on this side. So we're going to get A sine theta equals to the magnitude of the cross product of A and B over the magnitude of B. So how do we memorize this formula? So A is the vector that we are projecting from. So this is the original vector projected from. And B, which appears twice, is going to be the vector that we're projecting on. All right, so now let's say I have the point P0 here and the point P1. So how can we find the vector P0 to P1 using vector projections? So what we're going to see is that P0 to P1, the distance is equals to C. So now we can write the vector P0 to P1 as A dot B over the magnitude of B times the unit vector of B. So since we know that the unit vector of B, the magnitude is 1, so in other words, we're stretching the unit vector of B by a scale factor of C, which is this. Now we can rewrite this equation. You can rewrite the unit vector of B as B over the magnitude of B. So our equation is going to become the magnitude of A dot B over the magnitude of B squared times B.